If you remember, I had told you last time that if y is equal to fx is a function, that is, y is a function in x, then we define the differentiation of y, then the differentiation of y with respect to x is written as dy dx. Okay, or this is written as f dashed x, dy dx or f dashed x. That is, we write dy dx is equal to f dashed x. Okay, in terms of limits, dy dx or f dashed x is written as limit of h tends to 0 f x plus h minus fx divided by h. Right? Remember all this we had discussed? Yes, you remember all this we had discussed in class 11, the limit part.
Yes, sir.
Okay.
Yes, sir.
Now, when we different, this is also called differentiation from limits. We'll see how to differentiate from limits later on. Okay, but for the time being, we'll mechanically learn how to differentiate. Okay, how it actually works, the technical part, we'll see later. Okay, we'll see the how to find dy dx from limits later. Okay, right now we simply learn how to find dy dx. Okay, mechanically from the formula. So this is what we define dy dx as, and these were some of the results that I gave. The first result that I gave you was that the ddx of a constant is 0, where c is a constant. Okay, the differentiation of a constant is 0. Okay, and let me just mention that when I say dy dx, we also mean ddx of y, and we also mean ddx of fx. Okay, you can either write dy dx, or you can write ddx of y, or you can write ddx of fx. It's all the same thing. Okay, because y is equal to fx, y is a function of x. So that was the first result that I gave you last time. ddx of a constant is 0. So for example, if I want to find the ddx of half, it will be 0 because half is a constant. Okay, so that does not require many examples. And the next result that I gave you was a very important result, that was ddx of x to the power of n is equal to n x to the power of n minus 1. This is a very important result that I gave you, where n cannot be equal to 0. Okay, and this all this ddx of x to the power of n is equal to nx to the power of n minus 1 can be shown from limits. Okay, we'll see this later, how to find, how to why ddx of x to the power of n is equal to nx to the power of n minus 1. We can derive this from limits. Okay, which we'll see later. So examples. Suppose you want to find ddx of x to the power of 9. Okay, then this is, here n is 9, 9x to the power of 9 minus 1, which is 9x to the power of 8. Okay, suppose you want to find ddx of x to the power of 5 by 2, then this is 5 by 2 x to the power of 5 by 2 minus 1, which is 5 by 2 x to the power of 3 by 2, okay? Which can also be written as 5 by 2 x to the power of half cube, which can be written as 5 by 2 root x cube, which can be written as 5 by 2 root x into root x into root x. Now 2 root x combined to give you as simply as 1 root x, you get x root x. Okay. So that is how this you can use this result. Okay. The next result that I gave you was now before that you can now 3 results based on this you have to remember. Okay. Even without using x to the power of n, you must be able to say this. The first is that the ddx of square root of x, which is ddx can be written as x to the power of half, is equal to half x to the power of half minus 1. Okay, which is half x to the power of half, you'll get minus half, in fact half x to the power of minus half, which you can write this as 1 by twice x to the power of half, which you get 1 by 2 root x. Okay, so remember, whenever you are getting in your problem the ddx of root x, remember to directly write 1 by 2 root x. You don't need to do all these steps. This is just I have done to show you. Okay, so ddx of root x is equal to 1 by 2 root x by heart. Okay, next ddx of x to the power of 1 by x can be written as ddx of x to the power of minus 1. Again using n x to the power of n minus 1 x to the power of minus 1 minus 1. So you get minus 2 x to the power of minus 2. So you get minus 2 by x square. Okay, so please remember that ddx of 1 by x is minus 1 by, this is not 2, simply 1. ddx of 1 by x is minus 1 by x square. Okay, so directly you must be able to write ddx of 1 by x is equal to minus 1 by x. Okay, and also finally remember the very simple one, this ddx of x is equal to 1 into x to the power of 1 minus 1, which is equal to x to the power of 0 is equal to 1. So ddx of x is always 1. Clear?
Yes, sir.
Next result that I gave you was third one. I think in this only I should add. Yes, let me add in this only. The fourth one. ddx of, remember also this, ddx of a linear polynomial, that is ddx of ax plus b, where a and b are constants. When it is raised to the power of n, how will you differentiate this? You will first use nx to the power of n minus 1, n into ax plus b to the power of n minus 1 into a. Remember this. Okay. Along with all this, we are actually getting this from x to the power of n only. But how we are actually getting this, we'll see from chain rules later. But for the time being, you please remember this result. Let me give you one example from this. Example, ddx, if I want to differentiate ddx of 2x plus 3 whole to the power of 5, then this will be 5 into 2x plus 3 to the power of 5 minus 1 into 5. Okay, which is 25 times 2x plus 3 to the power of. No questions here? Remember again number 5, ddx, this is also a very important note, ddx of root ax plus b. ddx of root ax plus b, if you get, this is 1 by 2 root ax plus b into a, which is equal to a by 2 root ax plus b. Okay. Please remember these two. These two are very, very important. Most frequently, you will come across these two. Most frequently. Okay. So example.
Sir,
Yes, tell me.
number four's example, that will be 10, not 25.
No, this is 5 into 5, 25. This is 5 multiplied by 5, not plus 5.
Oh, that will be 2 now. 5 into 2, that will be not 5.
Okay. Okay. Yes, this will be 2 because a here is 2. This is 10. Fine. So the next one is ddx of root ax plus b. Um, so an example, let's take an example here. ddx of uh, root 5x plus 4. If you want to differentiate this, simply write this as 1 by 2 root 5x plus 4 into the coefficient of x, which is 5. So this is 5 by 2 root 5x plus 4. Okay. So for the time being, please remember these two. How we are getting this? We are actually getting these from chain rules. We'll see later. Okay. But for the time being, just remember these. Um, so this is what, and also what I discussed in the last class was that if you, and apart from these formula that I gave you, what I also discussed in the last class was that if u and v are two functions of x, if u and v, remember u and v are not constants. If u and v are two differentiable functions of x. Now, what do you mean by differentiable? We'll again see this definition later. But for the time being, remember that u and v should be differentiable. If your u and v are differentiable functions of x, okay, then let's say u, v, and w. Let's take 3, because in the end, I'll give you a result with 3 also. If u, v, and w are 3 differentiable functions of x, okay, then the following results hold. First is ddx of u plus or minus v is equal to du dx or ddx of u plus or minus ddx of v or dv dx. Okay, this will hold. Now, let me give you an example based for this, and then we can proceed. Also, extension of this can be, you can have any number of functions. Why only 2? Why only u and v? You can have ddx of u plus or minus v plus or minus w plus or minus, and so on. You can have, and this will be du dx plus or minus dv dx plus or minus dw dx and plus or minus and so on. Okay, so this is an extension. And example, an example of this is let us take ddx of, say I want to find x to the power of 4 plus 9. Okay, then how do I do it? What I do is I take them separately, ddx of x to the power of 4 plus ddx of 9. And I know ddx of x to the power of 4 to be 4x cubed and x to the power of n minus 1 plus 0, which is simply 4x. Okay, perfect example to start with. Next one is second. The next relation that you must remember is that ddx of a constant, let's say k, into u, where u is a function of x, must be equal to, whenever you can take this constant out of this differentiation to write this as k times du dx. Okay, so what can be an example of this? Let's see. Example, if I want to differentiate ddx of, if I want to differentiate this function, say x cube plus 4x square plus 3x plus 5. Suppose I want to differentiate this, then how will I differentiate according to this rule? First of all, according to the first rule, we will separate this ddx x cube plus ddx 4x square plus ddx. Uh, Later on, you will be jumping steps. Okay, for the time being, I'm showing you each and every step. Later on, we'll be doing this in just one step. Okay, so ddx x cube, is 3x square, and here this 4 will come out because of this rule, ddx of ku is equal to k du dx. This 4 will come out of the differentiation. We'll get 4 times ddx of x square, and this 3 will come out of the differentiation here. We get 3 ddx of x, and ddx of 5 as a constant, it will become 0. So you get 3x square plus 4 times. Now ddx of x square is 2x, and x to the power of n minus 1 if you use, and ddx of x, I told you to remember, is always 1. So this becomes 3x square plus 8x plus 3. Clear? How to differentiate this? So this is the second rule. The third rule was that the ddx of the product of two functions, ddx of u into v, uv rule, if you remember, okay, is first function you take, you differentiate the second with respect to x. Then you take the second function and you differentiate it with respect to x. Okay, this is called the u into v rule, or simply uv rule of differentiation. Understood? Extension, you can have three functions also. ddx of uvw can be, you take two functions as it is, differentiate the third, then you take the other two, say uw we take, differentiate the second, and finally you take the remaining two, that is vw, and differentiate the third. Clear this rule? You can have this for four also. You want this for 4 functions also. For 4 functions, let's write, just for your understanding, I'll give you for 4 functions also. For 4 differentiable functions, although we don't normally use 4 functions, but this is just for your understanding. For 4 differentiable functions, u, v, say w, and let's say say 5, for 4 differentiable functions, ddx of u, v, w, and 5. The product of these 4 will be, take 3 functions, differentiate the fourth, then take the next 3, u, v, 5, dw dx. Next, let us take the vw5 and differentiate this du dx. Next, let us take vw u d5 dx, right? Let's take w5 u dv dx and w5 v dw dx. Okay, I think this is a set of all combinations, no other combination. Yes, there are combinations, and this will continue. Okay, You take 3 and continue differentiating the third. So this will continue. Fine. So there will be many combinations from this. You're taking 3, so 4C3. There will be many combinations.
So we need to remember this.
No, this is just for your understanding. You will not require 4 functions, but 3 functions you may require. Okay. U into V rule definitely you will require. Yes, tell
We
me.
can do 3 with chain rule also.
Yes, you can. You can do by chain rules, but this is as I told you that 3 functions you will require hardly. You mainly you will require U into V rule. Okay, so when we'll come to chain rules, we'll discuss how to do by chain rules also. For the time being, you remember 2 functions definitely you will remember. 3 functions, try to see the because it is not too difficult to remember. If you know for 2 functions, you'll be able to do for 3 functions also. So no problem there. And for 4 functions, I've shown you for 4 functions just so that to show you the pattern, nothing else. Okay, this is your U into V rule, and you have your next result, which is the quotient rule. This is also called as the product rule of differentiation. Okay, or product rule of differentiation. UV rule is also called the product rule of differentiation. Okay, and we now come to the quotient rule of differentiation, or U by V rule. So ddx of U by V is equal to, take the denominator, differentiate the numerator with respect to x. So V du dx minus, take the numerator, differentiate the denominator with respect to x, and divide the whole thing by the square of the denominator. Okay, this is called the U by V rule of differentiation. This is called the U by V rule or quotient rule. Of differentiation. Okay, let us see an example to demonstrate U into V rule and U by V rule. Okay, let us see this together. Both. Example, very simple one. Then I'll come to the problems later on. Okay, let us say that suppose I give you y is equal to this one. Y is equal to 2x square minus 1 into x cube plus 4 cube. Let's say x cube plus 4 simply. X cube plus 4 cube will also do. Fine. How to do this? So therefore, what should be dy dx? Dy dx is equal to ddx of, we'll use u into v rule here, 2x square minus 1 into x cube plus 4 whole cube. Let us not take whole cube. Let us take simply. Okay, so simply you have been given 2x y is equal to 2x square minus 1 into x cube plus 4. We'll use u into v rule. We'll take the first function, 2x square minus 1, differentiate the next one. Then we'll take the second function and differentiate the first one. Okay, and how to differentiate now? Now we differentiate in the usual manner. So 2x square minus 1 and ddx of x cube will be ddx of x cube u plus or minus v is equal to du dx plus dv dx. That's what we are using here. Okay, we distribute the differentiation over x cube and 4 plus x cube plus 4 into ddx of 2x square plus ddx of 1. Okay, so you get 2x square minus 1 into ddx of 3x cube, you know, is 3x square, and ddx of 4 is 0. Okay, plus x cube plus 4 into the ddx of 2x square. You take 2 out of the differentiation, 2 ddx of x square, and this is 0, is equal to 3x square into 2x square minus 1 plus x cube plus 4. Now see here, 2 into this one is twice of ddx of x square is 2x, right? And plus 0, so we omit that. So this is 3x square into 2x square minus 1 plus 4x times x cube plus 4. Now if you want, you can simplify this a little. You get 6x to the power of 4 here. 6x to the power of 4 minus 3x square plus 4x to the power of 4 plus 16x. Okay, so this what you're going to get is 10x to the power of 4 minus 3x square plus 16x. Any questions on u into v rule from this example? Any step that you could not understand?
No, sir.
Now, I will do the same differentiation without the u into v rule, and this is going to be easier. I would prefer in this problem. Okay, I'm not saying that u into v rule is useless, but in this kind of problem, when product of two polynomials are given to you, see this is a polynomial, right? 2x square minus 1 and x cube plus 4. These two are polynomials. Whenever product of two polynomials or at the most three polynomials, if they are given to you, then it is always better to multiply them and then differentiate. Okay, we'll see how. Alternatively, given what was given to you, was y is equal to 2x cube 2x square, sorry, 2x square minus 1 into x cube plus 4. Okay, so now what we now here do is we multiply these two, because only two, it is a product of only two algebraic polynomials. Okay, so we'll multiply these two to get 2x to the power of 5. Okay, plus you get 8x square. Okay, minus x cube minus 4. Okay, so this is what we are getting. Once you multiply, now it becomes very easy to differentiate. Therefore, dy dx is equal to ddx of 2x to the power of 5 plus 8x square minus x cube minus 4. So now you distribute the differentiation over each and every term. 2x to the power of 5 plus ddx 8x square minus ddx x cube minus ddx of 4. Okay, so now you'll have twice ddx, because you can take this constant out of the differentiation, x to the power of 5 plus again this constant taken out of the differentiation, 8 ddx x square minus, now ddx of x cube, you use the result nx to the power of n minus 1 to get 3x square, and ddx of 4 is a constant, it becomes 0. Now in the next step, twice, now we'll differentiate x to the power of 5. X to the power of 5 is 5x to the power of 4 plus 8 square is 2x minus 3x square. Okay, so ultimately you get 10x to the power of 4 plus 16x minus 3x square, as we were getting earlier. Okay, just as we were getting earlier, we're getting this, now we're getting this. Now see that when we are multiplied, it actually becomes a little easier. When it is a product of 2 or 3 polynomials, try to multiply and then work instead of applying UV rule directly. Though the logarithmic differentiation also works, we'll see later. Okay, but for the time being, just remember if this is product of 2 or more polynomials, then it is always easier to multiply than use U into V rule. Though you can use U into V rule also. So this is one of the examples. Now U into V rule especially is good when trigonometric, when a product of algebraic function and or a polynomial and a trigonometric function is given, or a product of say an algebraic function and in fact not an algebraic function, a polynomial and a trigonometric function is given. Say for example, I'm not working this out. Suppose for example y is equal to, it is given to you 2x plus 1 sin x. Okay, we'll see later how to do this, but for the time being, just see this. This is a product of 2. With this, if you take this part as u and this part as v, okay, then you can work this out by u into v rule. Okay, then u and v rule is very useful. But in case of product of 2 polynomials, it is always easier to multiply the polynomials and then work instead of using u into v rule. So you'll be using u into v rule very extensively later on, when we come across trigonometric functions, inverse trigonometric functions, and so on. So this was one demonstration of U into V rule. Okay, we'll see one demonstration of U by V rule also, and we'll take something that is very simple. And one more rule is left, okay, for you. But we'll just see one demonstration of U into V rule. Example, this is example number, say A, and we'll take example number B now. They're given to demonstrate this. Let us take y is equal to, yes, let's take y is equal to 3x to the power of 4 by 1 minus x to the power of 7. Okay, so how do you use this? How do you differentiate this? Therefore, dy dx is equal to ddx of 3x to the power of 4 by 1 minus x to the power of 7. Now using the u by v rule, what was u by v rule? Denominator v, take as it is, into du dx, differentiation of the numerator, minus the numerator v into differentiation of the denominator. So numerator is u, then into dv dx, 1 minus x to the power of 7, divided by the square of the denominator. Okay. Now which is equal to 1 minus x to the power of 7. ddx of 3x to the power of, take the constant out, 3 becomes 3 ddx of x to the power of 4 minus 3x to the power of 4. Now see here, ddx of 1 minus x to the power of 7. Okay, how do you differentiate this? See, if you compare with the ddx of ax plus b to the power of n, this rule I told you to remember, this was n into ax plus b to the power of n minus 1, isn't it? So if you compare this, a here is what? A here is minus 1, because this is minus 1 here, isn't it? And what is b here? B here is 1. N here is 7. So if you differentiate this, what are you going to get? You're going to get n into 1 minus x to the power of 6 into, what is the coefficient of a here? X here, minus 1 into minus 1. So this derivative will be minus 7 into 1 minus x to the power of minus 6 into to the power of 6. Is it clear, this one?
Yes.
So this will be minus 7 into 1 minus x to the power of 6 whole divided by 1 minus x to the power of 14. Okay, so this is 1 minus x whole to the power of 7, and ddx x to the power of 4 is 4x cubed. You already got a 3, so this will become 4x cubed minus, and minus minus combined to become a plus. Okay, and you get 3x 21. You get 7 into 3 is 21. 21x to the power of 4 into 1 minus x to the power of 6 divided by 1 minus x to the power of 14. You can simplify this a little by taking 1 minus x to the power of 6 common. 1 minus x to the power of 6, because this power is 7 and this power is 6. So definitely you can take 1 minus x to the power of 6 out of the 2, so that you get here 4x cubed into 1 minus x simply plus 21 times x to the power of 4 whole divided by 1 minus x to the power of 14. Okay, so now what you can do is this powers will cancel here, 6 and this become 14 minus 6 here. 14 minus 6 is how much? 8, right? So this will become 4x cubed into 1 minus x plus 21x to the power of 4 divided by 1 minus x to the power of 8. You can simplify this a little further. You can open the brackets, multiply everything. So this becomes 4x to the power of 4 minus 4x cubed. First one will be 4x cubed. 4x cubed minus 4x to the power of 4 plus 21x to the power of 4 by 1 minus x to the power of 8. And therefore you have this as 21 minus 4 is 17, x to the power of 4 minus 4x cubed by 1 minus x to the power of 8. Which you can also, a little better way of writing this is taking x cubed common, 17x minus 4 divided by 1 minus x to the power of 8. Okay, that is your answer by UV rule. Okay, I'll stop here for today.